I'll now talk about trigonometry application. First, before you begin working on a quiz or your homework or a test, you should always write SOHCAHTOA at the top of your paper so you remember what trig function to use. Again, SOHCAHTOA stands for sine, cosine, and tan, opposite, hypotenuse, and adjacent. So let's suppose I have a tree in my yard that needs work at the top of the tree, and the guy that's going to come work on it says, well, how tall is your tree? Well, I have no idea how tall the tree is, so I use trusty Trig to measure it. I walk 100 feet away from the tree, and I use an instrument called a clinometer to get the angle of elevation, which is the angle when I look out and up at something. And that angle, let's say, is 65 degrees. I then mark my opposite, adjacent, and hypotenuse in relation to that angle. Assuming the tree is standing at a right angle, I find the hypotenuse first across from the right angle. Then I look at the angle I'm working with and go opposite it and mark that side opposite. And then the other side is my adjacent side. I put an X on the part of the problem that I'm trying to find. In this case, I'm trying to find the length of the height of the tree. So I like to circle the two parts that are marked on my drawing, and then I look up at SOHCAHTOA and decide which trig function to use. In this case, I'm using opposite and adjacent, so that would be tangent. So I write the tangent, and then after that always comes the angle. The angle I'm working with is 65 degrees. And by definition, tangent is opposite over adjacent. So I take the opposite side, which is x, and divide by the adjacent side, which is 100. I now get the x alone, so because it's a fraction, I multiply both sides by 100. And I plug into the calculator 100 tan 65. Now, it's extremely important that you make sure that at this point your calculator's mode is degrees. So press the mode, M-O-D-E button, and look and make sure that underneath that you see degrees highlighted. If not, move it over and hit enter. Once you have it highlighted, go back and just press 100 tan 65. And that's the height of the tree. So when I do that, I get 214.45. And make sure you use units, in this case feet, because I had said I walked out 100 feet. Don't forget, if you've really used an instrument to measure the height of the angle there to the top of the tree, you need to add in your height. Let's say I'm 5.5 feet tall in order to get the true height of the tree. Okay, my second example has a pilot in a plane. Let's say he's 4,000 feet above the ground, and he sights an airport, and he knows his angle of depression, which is his angle when he looks out and down at something. His angle of depression is 23 degrees, let's say. The question is, how far away is he from the airport? We said that the height that the pilot is at that moment is 4,000 feet above the ground. So my angle is 23 degrees, and unfortunately it's not inside the triangle. However, we know that this angle right here is 90 degrees also. So 90 minus 23 gives you a 67 degree angle right there, and we can use that as our angle. Again, find the hypotenuse first, opposite the right angle. Then go opposite the angle you're working with and mark that O, and then put an A on the remaining side. Circle the two parts of the problem that you're interested in working with, and then look at SOHCAHTOA. So, Ka, C-A over H, TOA. And we see that we're working with adjacent and hypotenuse, so that's cosine. So I'm going to set up cosine of the angle, 67 degrees, equals adjacent, which is 4,000, over x. Now, unfortunately, x is in the denominator this time, so we have to get it out of the denominator, so I'm going to multiply both sides by x. and write x cosine 67 degrees equals 4,000. I still have to get the x alone, so if x is in the denominator, it's a two-step problem. To get the x alone this time, there's multiplication there, so I'm going to divide by cosine 67 degrees. And then I just plug that into my calculator. 4,000 divided by cosine 67 degrees. Again, make sure your calculator is in degree mode. So x in this case is equal to 10,237 feet. My last example in this movie deals with let's say a cell phone tower. And we know the cell phone tower is, I don't know, 50 feet tall. And we need to put a wire on the cell phone tower from the top to hold it so that it doesn't fall over. So the question is, how long does that wire have to be? For safety purposes, we want the angle of elevation from the bottom of the wire when you look out and up to the top of the tower. We want that angle to be 62 degrees. So again, put an X on the part that you're trying to find, which is how long that wire has to be. So I look at the sides of the triangle that I'm working with in relation to the right angle. X is the hypotenuse straight across. Opposite the 62 is this 50 right over here, and then my last side would be A. And I'm working O and H this time, which happens to be sine. So I set up sine 62 degrees equals O over H, 50 over X. In this problem, x is in the denominator, so I multiply both sides by x. That reduces the right side to be 50. On the left side, I have set x sine 62 degrees. To get the x alone, I divide by sine 62. And in the calculator, plug in 50 divided by sine 62. And I know my wire needs to be 56.62 feet long. My last example will be finding an angle. Let's suppose you have a right triangle and you know one side is 7 and the other side is 4, and we have a right angle right here, and we're interested in this angle right up here. We'll call it x. So again, mark OA and H. H is opposite the hypotenuse. O is opposite the angle we're interested in, which would be 7, and A would be our 4 over there. Circle the sides you're working with, which in this case is A and O, and that's our tangent, O over A. So I'm going to set up the tangent of the angle equals O over A. Notice we don't know the angle in this case. So O is 7 over 4. I want to get rid of the word tangent or the tangent function, but I can't divide by a word. So instead you use the opposite operation, which is called the inverse tan, and is denoted in your calculator tan to the negative 1. So when you take tan to the negative 1 to both sides, you know from previously that when you take a function and its inverse, they cancel each other out and you just get x. In your calculator, plug in second tan, which is inverse tan, 7 divided by 4, and it will give you 60.26 approximately degrees.